All right, welcome back to the sixth challenge of Damn Vulnerable DeFi. This one is going to be called Selfie, so let's go ahead and get into it. A new cool lending pool has launched. It's now offering flash loans of DVT tokens. Wow, and it even includes a really fancy governance mechanism to control it. What could go wrong, right? You start with no DVT tokens in balance. The pool has 1.5 million tokens. Your objective? Take them all. All right, let's go ahead and take a look. So we have this Selfie pool contract here, and it has the token, the government's thing that we'll take a look at in a sec. So this other contract has funds drained event, a new modifier. So if you don't know what a modifier is in Solidity, it's basically like a kind of a modifier that you can add to a function that runs before the function runs. So in this case, it's only government. So if this is this modifier is on a function, it only allows the address of the governance to run that function. In the constructor, we have the token and the governments set up, so no problem there. And we have two functions here. We have flash loan and drain all funds. So that looks very interesting. But let's have a look at flash loan. So the balance before, classic, we've seen this before, verifies that there's enough tokens in the pool to do the flash loan. It then transfers to the sender the borrow amount. And after that, it verifies or it requires that the sender is a contract. So we need to deploy a contract to solve this, or to execute a flash loan at least. And then it calls the function call with signature, as we've seen before, how this works. But it's going to call the receive tokens function with an address and a uint256 parameter. And it's going to pass in the address of the token and the amount we borrowed. Finally, it's just going to verify that the flash loan has been repaid back afterwards. So nothing too crazy new there that we haven't seen. Let's go ahead and take a look at the drain all funds function. So this takes in a parameter of the receiver. And again, it's got this modifier of only governance. So only the governance contract, again, up here, set up over here, is going to be able to execute this. And the way that this works is it gets the token balance of this address. It then transfers that token balance to the receiver that's been passed in. And then it emits this funds drained event. Cool. All right. So there's nothing really here that looks too exploitable. Let's go ahead and look at the simple governance protocol, contract, sorry. So this one is a little bit longer, but again, it's not too complex. It creates a governance action struct, which is kind of like a custom object or class in other languages. We have the governance token, which is a damn valuable token snapshot. So this looks interesting. We have a mapping from a number to the governance action, so they're just the action, and this is going to map to the specific class up here. We then have the action counter, the action delay in days, which is 2 days, 2 more events defined, and then we have our constructor. So in the constructor, we verify that the governance token address is not 0, and the governance token is equal to the damn valuable token snapshot of the governance token address, and that the action counter is 1. Okay. So then we have, so this is basically just starting off the action counter. Let's have a look at queue action. So to queue an action, we need a receiver, the call data or data, and the amount in way that's going to be sent to the address. So basically what this allows to do is essentially if an action is to be proposed, you can pass this in and the proposal is coded into the contract. So what you need to perform is actually done in code and then it's passed into the contract. And if enough people approve it, then it can actually go ahead and execute it. So firstly, it requires that it has enough votes for the message.sender. So let's have a look at what that means. Have enough votes. So it's going to have the account and verify that the balance at the last snapshot of the account to be greater than half of the total supply. So it's going to get the total supply divided by 2, half of the total supply divided by 2, and verify that our balance is greater than that. So if we have enough governance tokens to be greater than half of the supply, we have enough votes. So continuing along, if the receiver doesn't equal this address, we cannot queue actions that affect governance, right? So you cannot create an action that will interact with the governance token, the governance contract itself. All right, that's another constraint we need to work with. The action ID is the action counter. That's going to be 1. And so then basically builds out this struct up here, so with all the actions that it needs to do, and then it saves it. So the actions ID is the action to queue, and it saves it all in, increments the action counter, and then emits an action queued event. Cool. All right. The next thing is execute action. So we've queued that action that we want to do, and remember that there's the delay of in seconds, which is 2 days. And it's going to firstly, the action to execute, it's going to retrieve it. It's then going to look at when this can be executed at. So executed at is action to execute. Where is it? Oh, no, it just literally sets it. Executed at block.timestamp. So I'm going to execute this action. It's going to be executed at this timestamp. And then it's going to basically call the action. So the function call with value, it's then going to, there's the data that it wants to call, so the function and the arguments that you want to call with it, and the amount that you want to transfer with it, and then it emits the event of action executed. So this is the idea of using governance to manage your contract or whatever kind of governance thing that you want to do. Let's have a look. So we have get action delay, which just returns the action delay in seconds. And we have another function here called can be executed. So an action can only be executed if it's never been executed before and enough time has passed since it was first proposed. So if we have a look, we can see that to make sure that the executed at is 0, so it has never been executed before, and the timestamp of the block minus the action to execute proposed at is greater than or equal to the action delay in seconds. All right, so that's pretty cool. There's nothing too complex here. So this is the governance thing. So how do we break this? How do we win? How do we win? So the first thing that we need to do is essentially retrieve so the governance token here, I think, is important to clarify. The governance token is the same liquidity token in the Selfie pool, or the lending pool. So the simple governance is the governance contract, and then the token here, which is the ERC token, ERC20 snapshot, is the same, right? So that's really important to know. So what happens is when we borrow these funds, we then are borrowing the amount of governance funds, essentially. So we can borrow governance funds, which is really not a good thing that you should be able to do. So we can kind of start to build up an exploit here. So if we can borrow any amount of funds, then we can, in that one transaction with the flash loan, we can schedule a new action to happen because we have greater than 50% of the funds. We know this because we can see that in the setup of the thing, we can see that the token initial supply is 2 million and the tokens in the pool is 1.5 million. So if we borrow the 1.5, then we have 75% of all total tokens, meaning that we can actually, we can schedule these actions to happen. Once we schedule the action to happen, we then need to wait 2 days to for it to get to the past that. Where is it? The action delay. So we just need to wait 2 days. Once that schedule is the action scheduled, and then once that's done, we can just execute it because anyone can actually execute it. You can see execute action. There's no modifier. It doesn't require anything. It just needs to be able to be executed. So it's really quite simple. Flash loan, schedule an action, wait 2 days. And then execute that action. Now, what action do we want to execute? Well, there's a really handy function here called drain all funds. And this can only be called by the governance contract, which will execute it on our behalf because it's using the execute action. We then just transfer this all to our account, and there it is, and that's it, and that's done. So how do we do that? Let's take a look at the contract first. So we're going to create a new function, a new contract here called attack selfie.sol. And this is our attacking contract here. So we set up a few things in the constructor here. So we have our selfie pool, the damn valuable token snapshot, which is the governance token that's been used that we're going to borrow, and the address of the owner. So the owner is going to be the attacker. And we have 2 functions here. The first one, again, attack. So we're going to get the amount to borrow from the balance of the address pool. So we want to get everything from the pool. We could also pass this in as a parameter, but in this exploit, I didn't. And then we're just going to do a flash loan of the amount to borrow. So let's follow the logic here. Flash loan comes into the Selfie pool. Selfie pool goes flash loan, goes through all this kind of stuff, sends it to us, and then we get this callback, right? So once we have the tokens transferred to us, we then need to implement this receive tokens function with the address and the borrow amount. So we implement this here, and we can see that we're receiving these tokens. Now this has an unused function parameter, but we just need that so that the function selector is correct. And we then go ahead and execute these steps. So first thing, we need to take a snapshot. So a snapshot can be taken by anyone, right? And so remember when this is actually looking at if you're able to schedule an action. Let's have a look. It gets the balance at the last snapshot for this account. So what we need to do is make sure that once we have the funds, we create a new snapshot so that it updates our address. So let's go ahead and see how that works. So once we've done that, we hit snapshot. And this isn't implemented in this function or this contract here. It's actually implemented in the governance. Where is it? Get balance at last snapshot. Oh, there we go. So you can see this is in the damn valuable token snapshot. And so this is the snapshot function here. So once that's done, we then we now have 75% of all the tokens. We want to queue the action. So what action do we want to queue? We go pool.governance. And the reason I'm doing this is just for convenience sake. So we know we have the pool. This is the lending pool here. We can access the governance token, governance contract via this pool. So this is just an address essentially in this contract. So we go pool.governance.queueAction. So queueAction is this guy here. And we've got to pass in all 4 of these. Oh, no, we only just need to, we need to pass in the correct parameters, right? So the first thing is we need to pass in the receiver. So the receiver is going to be the address of the pool. So we want the action to drain all funds to go to the address of the lending pool. We're then going to encode with the signature, the data. So we want to call the drain all funds address, and we want to pass the owner argument as the address that we want to call. And the value that we want to transfer is 0. So again, receiver, data, the amount that we want to transfer is 0. We don't really need to transfer any money. That's fine. So we queue that action. That's going to validate because we have enough tokens. And then we just need to transfer the amount of the pool, transfer to the pool the amount that we've just borrowed. So everything that we just borrowed, give it back to the flash loan so that transaction goes through. Cool. And that's it. So what happens after that? All we need to do after that is wait the 2 days, or in our case, we can just ask the EVM to move forward 2 days. And we then execute the action. So let's have a look at what that means in code. So we have our exploit here. Let's go ahead and get the code. So the first thing that we're going to do is run the attack. So we're going to deploy our contract, attack Selfie, and we're going to deploy it with the correct parameters of the contracts and the owner address as well. And we're just going to run the attack. So that's going to go ahead and do all the actions that we just ran through then. After that, we're going to go and increase the time by 2 days. In real life, you would just wait 2 days. I believe I'm going by 5 days here. It doesn't actually matter, but 2 days, never mind. Okay, cool. The next thing that we need to do is execute the action. So as an attacker or as anyone, we can just go ahead and execute it. So I'm going to connect to the government's contract as the attacker to make sure this is a real life situation. And we just go execute action 1. Now, why do we pass in 1? Because it is the first action that has been deployed. And that is defined by the, sorry, it's up here. The action counter here. So that starts at 1 and then 2 and then 3, 4, 5 all the way up. So let's go ahead and see if we can drain this pool. So let's go ahead and run yarn run Selfie. And let's see if we meet these success conditions of the token balance of the attacker address to be equal to the tokens in the pool, and the balance of the pool to be equal to 0. And there we go. So that's how you do the selfie challenge. I hope you guys learned something from that, and I will catch you guys in the next one. See you later.